Tonight I'm going to talk to you about a revolutionary new product called 4Ride Mobile that's rethinking the way that we use university transportation. Currently, GW offers 4Ride, which is an on-demand student shuttle service that operates between the hours of 8 p.m. and 4 a.m. While this service has become extremely popular among students on campus, it suffers from three weaknesses that prevent it from being an ideal implementation. For one, it has inefficient scheduling. Two, it has an unintuitive scheduling interface. And three, it has unreliable communication between students and drivers. Let's take a look at how the service is laid out. As we can see on the bottom left, there are two factors that make the student end very confusing and frustrating. You access the service using the MyGW web portal, which provides desktop interface forms that are not very useful on mobile. Once a request is made, it gets sent to a server and then relayed to a dispatch center. While dispatchers manually assign these vehicles and probably have a great deal of experience doing it, they don't consider every factor every time they make an assignment. So they won't always know what the ideal itinerary is, considering traffic patterns or maybe student behavior using the service. But once these assignments are made, they then get passed down to the driver, and then the driver is able to proceed with the request. As you can see from this system, this is very one-directional, and students may not understand anything that's happening downstream if problems do occur. There's no direct communication between drivers and students. 4Ride Mobile attacks these three weaknesses head-on by using elegant scheduling, effective communication, and most importantly, an awesome interface. Let me give you a little demo on how this works. Before I start, let me just point out a couple components of the system. For one, at the bottom of the iPhone dock, you can see that there's a student and there's a driver app. These apps provide the student and the driver respective access to the system. On the right, we can also see that there's a map, and this map is a bird's eye view that allows dispatchers to be able to see real-time changes in driver routes, vehicle locations, and drop-off and pick-up locations along these routes. So let's get started. We'll pretend that we're a student interacting with 4Ride Mobile. We can see first that there's three outstanding vehicles, and we can see information like driver name and the capacity. We next put in a location that we'd like to go to and simply press request. Immediately we get feedback on the nature of our request. We can see that 4Ride's on our way, we know the name is Mr. Dillard, and we know that it's 0.15 miles away. We also know information about when it's coming. Now, as the driver, we can also see information immediately on our side. So we're taking a look right now at Mr. Dillard's itinerary. We can see in his itinerary a list of locations where we're now at the top, which means that although we're not the highest priority, the distance and traffic factors overrode that and made us the next location. So let's see what he does. In response, all he has to do is tap when he arrives at our location, and there's automatic feedback from the server. We can also see on the student side that we'll get changes contextually in the options that we have once we're picked up. We can change the destination if we decide without really affecting Mr. Dillard in any big way. So let's say that we want to do some sightseeing instead of going to New Hampshire Avenue, and we just go to the White House. We'll type that in, we'll press submit, and we can see that this not only appears immediately on our screen, but it will also appear on the blue route on the dispatch module as well, indicating that the server updated in real time. We can also do different types of things, like let's say we just want to get dropped off right there and then. We can do that as well, and we can see on the map that now the White House has been removed from Mr. Dillard's route. Now that we've seen how 4Ride Mobile works, let me explain to you a little bit about the underlying mechanics. We can see all these different request handlers that were happening in the demo, such as early drop-off, destination change, and basic pickups. That all occurs in the request handlers. These request handlers accept post calls and return JSON data to any of the clients requesting these calls. Also, vehicle objects store information about the vehicle, simple information such as the driver's name and the capacity, but also the itineraries, which are evolving in real time. The server also does a lot of caching. The request cache allows the server to issue a unique ID to the clients making a request. That way there doesn't have to be this insecure and inefficient passback of information every time the client wishes to make a new request. The geocode cache is also a very good way of caching geocoding, so I don't have to make a call to the Google Maps API every time a new request comes in. Theoretically, as the cache grows bigger and the server is used, then it will become much more efficient. But the most important thing is, how do I actually do the scheduling? We can see on the left that the way I actually store these itineraries in the vehicle is not just as a list, but as a weighted digraph with the locations as the nodes. There's a couple things I'd like to point out about this. The first thing is, you can see that the green points and red points must be different in some way. The green points are just pickup points, and the red points are just destination points. So we can see that the pair furthest to the left is 1, because they're both part of the same request. Now also there's some constraints here. We can see that there's only one directional arrows going out of the vehicle location. This is just to say that we're always going to start there in our itinerary. And this means that we're not going to ever go back. Also, it says, or we can see that there is only one directional arrows from pickup to drop-off points. And this is just indicating the precedence of pickups always having to come before drop-offs for our respective requests. But the most important thing you're also probably wondering is, how do we actually create these weights and what do they mean? Well, first, what they mean is it's just a cost of actually going between any 2 points. And the most intuitive thing that we consider in this is just distance. But distance is not the only consideration as you really start to think about this algorithm. You should also consider traffic patterns. You should consider priorities, which is what I've added into this system. But I know that there's a bunch of different things that I'm probably not thinking of. So I made the system extendable to add an indefinite number of additional factors in this weighted sum travel cost calculation. And now once I've got this graph, this is starting to look more and more like a traveling salesman problem. The problem is that I have a lot more constraints than a basic traveling salesman problem, and therefore the tour will as well. What I did was I started researching and realizing that this is actually a subclass of traveling salesman called dial-a-ride. And unfortunately, it's extremely computationally intensive. So what I did was I considered a number of different approximations based on the contextual nature of the data. I would scan the data first, and if it matched a certain set, then I would apply one approximation. Whereas if it applied to some other set, then I'd apply another approximation. This ended up being very efficient down the road and made for a service that was, as it needed to be, very effective and quick. While I have a very powerful and complex system, I wanted to make sure that the impact was simple and elegant. And it is, because what 4Ride Mobile does is provide a personal and real connection to students and drivers. This allows students to make sure that they can get between places like South Hall and Gelman with ease. And also, it's important to note that it's very safe. And due to the nature of 4Ride being late at night, it's nice to know, through effective communication and real-time scheduling, that I'm not going to have to worry about my vehicle not showing up. And also, which I find to be probably the most important thing, is the fact that this is not just a theoretical algorithm. This is something that I've been working in partnership with the SA and GW Transportation to make sure that I was building a system that was useful and practical for the university. In this way, 4Ride Mobile is not just some theoretical project that will end with this presentation, but it's something that we might see one day in actual GW Transportation infrastructure. Thank you.